Hi, in this video I want to talk about the applications of geological mapping to some of the issues around this place. This is Malmesbury in Wiltshire, and it's a location where, because of its geology, quarrying is important. This is based on the 2015 WJEC A level exam. You should by now have had a go at the questions. Let's have a look at some of the answers. This map shows us the locations of some of the quarries in this area, uh, and to and for us to be able to apply our understanding of geological maps to try and deal with some of the issues created by the need to extract carboniferous limestone from this location. Uh, Here we've got aerial photos of um, these two quarries that are shown on the map, and we can see the shape of these quarries, the differences between them, and also potentially some of the issues that are there. So the first question then, just to get us to look at the map, is to complete the table to describe these characteristics of quarry A and quarry B. To look at the angle of dip, its direction, and the limestones that's actually being extracted. This is our table, as is common for um, tables that are given in these exams. There'll be a bullet point um, next to the spaces you need to fill in. Okay, just as a little tip that you need to be putting something in that location. I've graded the boxes here just to emphasise that all the more. But in the exam, we're looking at looking for the bullet points to complete. So first of all, we've got a dip of 36 degrees in quarry A, and a rough dip direction to the west. In quarry B, the rock being quarried is called the Clifton Down limestone. If we look at the aerial photograph here, we can see that the limestone beds on the western face of quarry A look like they're horizontal. But the map clearly shows a 36 degree, a significant dip um, in this quarry. Now the answer is, of course, is what we're seeing is an apparent dip. We're actually, that quarry face roughly follows the strike of the beds. It's roughly north-south. So therefore, it really doesn't matter what the beds they're dipping at, they're going to always seem horizontal. Because what we're looking at is a strike cross-section. If we look at the generalized vertical section, um, the maximum thickness of these limestone beds in quarry A that have been identified in table 7, they're about 2 centimeters thick, times that by 96 for the scale, and we have a 200-meter maximum thickness. This is a cross section there through quarry A. We can then use this diagram to explain how the steepness of the quarry faces and therefore their stability are controlled by the dip of the beds. Unusually here, it says we are required to use annotation, so you must annotate this diagram. Now, obviously, the most useful thing to draw on here are some dip directions. So let's put some beds in. It doesn't matter exactly where these go, as long as you're showing sort of roughly the correct dip. So the correct angle and the correct direction, so 36 degrees to the west, and we should see some lines like that. Like I say, it doesn't matter exactly where you put those. Our annotations then, on the west there, we've got a very steep slope in the quarry here as the dip is going into the slope. That side therefore is stable. There are some rock steps cut there just to catch loose rocks and to increase the stability, but that side can be much steeper. The slopes on the east, on the other hand, clearly from this diagram, are much gentler because the dip here is coming out of the slope. There's a possibility of beds daylighting appearing in that bedding plane or in that surface of the quarry, so that surface is cut pretty much parallel to a bedding plane, possibly even a longer bedding plane. It does make this prone to landslip if a bedding plane has been dug through, and 36 degrees is probably greater than the basic friction angle of these rocks. So there's potential for instability there. Certainly, if this quarry on the eastern side was dug with a steeper slope as we see on the west. Now these two quarries can't be expanded particularly very greatly along their eastern or western margins. They could perhaps expand north and south, but there are some limitations east and west, both for Quarry A and Quarry B. The question says to look at one of these, so let's look at them in turn. Let's start with Quarry A. So for Quarry A, to the east, we've got an unconformity. We've got retic, which is sort of the Triassic-Jurassic transition, or shales or sandstones dipping beneath those beds. So clearly we're at the base of the limestone there. There may be no more limestone to the east of this quarry. To the west we've got rocks sitting on top, sandstones and mudstones that again may not have any economic value. It's the limestone here that's going to be valuable. For Quarry B, to the east, again we've got rocks of no value, sandstones and mudstones. To the west, we have an unconformity of the Triassic, as that eroded away the limestone that we're really interested in, and there's again rocks of not much economic value. Those are going to be the main limitations. You could though also discuss the width of outcrop to the depth. Okay, the more deeper you go in these quarries, the more difficult it becomes, the more it costs to extract the material. You could talk about the dip and the thickness of the beds, how deep they go. We could see from the aerial photograph that there are clearly water table issues in these quarries, with the bottom, certainly of Quarry A, being flooded. The question though is quite specific about geological factors. So if you've written out about anything non-geological, road, the farm, ploughed fields, habitat loss, anything like that, you won't get credit for it. Even if you feel that's an important factor, it's not a geological one. So, as we see the sunset of Malmesbury Abbey, remember, if you're asked for the geological factors in any of these questions, and there's a very good chance you will be, stay focused on the geology. Don't get distracted by things that stray off into perhaps the world of geography. If you've got any questions, get in touch. I'll see you next time.